Welcome, everybody. Good afternoon to those in the East, and good morning still to those in the West. Thanks for joining us for today's webinar. I'm Brandon Terry. I'm Director of RealLife Sales at High Sierra Electronics, or HSE as some folks know us. We're an advanced environmental monitoring, or AEM, family company. We also have our sister company, OneRain, joining in with us today. HSE and OneRain are leading providers of road weather solutions for many state and municipality in their road maintenance divisions here in the United States. Just a few housekeeping things before we get started today. If you have any questions during the presentation, please feel free to type them into the question box located in the WebEx window that we have on the screen. We'll be monitoring those throughout the webinar, and we can call those out as they come available. We have an appropriate time to do so. And also, we'll have some time available at the end of our presentation for some questions opened up to the floor. If you notice on the screen there in the bottom of your WebEx box, please be sure to mute your mics or turn your video off. You don't need your video on to actually view the presentation, so you can turn that off, and that will minimize distractions for everyone presenting and the crowd attending the webinar. It would be hugely appreciated. Today we're presenting effective use of road weather data, or mobile road weather data, in operations. We'll be providing you a brief tour of RealLife technologies and a few examples of how road maintenance operations personnel can utilize their mobile road weather sensor technology to help make better decisions in their winter weather maintenance operations. Now, without further ado, I'll introduce ourselves today. So I'm Brandon Terry. I've introduced myself previously. I am the Director of Sales at HSE. I have about 15 years of experience in the weather industry, working as a contractor with NOAA's National Weather Service for their field hydrology programs, particularly flash flood warning programs. And then with High Sierra as a flash flood warning system specialist and flooded roadway warning specialist. That kind of the marriage of hydrology and roadways brought me over to the RWIS space. And I've been doing the road weather stuff now for about 4.5 years. Next up, we've got Brett Hanson. He's the senior product manager, for the RWIS division at High Sierra. He's also a degree meteorologist from the University of Utah. Brett has over 15 years experience in the road weather industry, and he's dealt with everything from forecasting to installing and maintaining sensors on vehicles and stations on the side of the road. When he's not chasing road weather, he's chasing the stars with his telescope and his camera. He's quite the amateur astronomer. Next up from OneRain, we've got Charles Yost. Charles joined us from he joined OneRain back in 2013 as a meteorologist and a rainfall analyst. He holds a master's degree from Colorado State University with a focus on extreme precipitation. Charles is responsible for the strategic vision and development of the Contrail software platform at OneRain. And I don't know what Charles loves more, that precipitation or the LSU Tigers that he is undergrad alma mater from. All right, so what are we talking about today? We're going to go over first why road weather is important and why the information is important, the impacts of weather on the roadways and the impacts of maintaining our roadways, what tools are available to our decision makers in roadway maintenance. We're going to go through our road weather technology overview really briefly. We're going to go over mobile road weather vehicle architecture. I'm going to pass it over to Brett Hanson at that point. He's going to take us through that. How we use mobile road weather So how we use mobile road weather information in our operations, and then also we're going to take some scenarios and show you in some examples how we do that, and then we're going to start wrapping it up and say where is the mobile technology going down the road, and then we'll go over the takeaways from today. So we'll start off on why road weather information is important. There's no question that weather plays a huge role in how efficient the public travels about in vehicles, especially in winter months.
Would you please get my bedroom?
So 70% of the United States roads are in snowy regions. When we say snowy regions, we're meaning areas that get at least 5 inches of snowfall annually. And snow and ice play a huge factor in roadway hazard. Here's some statistics from FHWA, or the Federal Highway Administration, on traffic incidents in the U.S. On average, there are about 5.89 million vehicle crashes each year, and 21%, or around 1.2 million of these crashes, are weather related. On average, there are over about 418,000 people that are injured and nearly 5,000 people that are killed in these accidents. So if you notice in our graph here, wet pavement is the highest contributor to crashes on the highways, and then winter weather related roadway issues is the next leading cause. So what's the impacts of the weather on the roadways? Well, obviously, starting out, beyond just safety, there are huge factors that the weather plays on its influence in the roadways. Economically, adverse weather is most certainly increases operating and maintenance costs of winter road weather maintenance agencies and traffic management agencies, emergency management agencies, law enforcement agencies, and CVOs or commercial vehicle operators. On the public sector side, winter maintenance activities consume about 20% of the state's DOT annual budget, with direct cost of $2.3 billion and indirect cost of $5 billion annually. On the private sector side, each year trucking companies or CVOs lose an estimated 32.6 billion vehicle hours due to weather-related congestion in the 281 nation's most densely populated or metropolitan areas. The estimated cost of weather-related delay to trucking companies range from $2.2 billion to $3.5 billion annually. So environmental, there are many environmental impacts that de-icing and winter weather maintenance activities have on watersheds around the U.S. De-icing activities have been found to be the dominant source of salt in urban areas of the northern U.S., according to the United States Geological Survey study, or the USGS study that began as early as 1960 at some points, and then ended as late as 2011 in some locations. Chloride levels have increased substantially in 84% of the urban streams analyzed. The level were highest during the winter season, but basically during the off seasons, the level was increasing, but overall not as great as it was during the winter seasons. It's worth noting here that, not just the highway maintenance folks contributing to the increase, many private organizations are de-icing their parking lots and sidewalks using salt and other chemicals as well. And this is a runoff product that makes it into local stormwater systems also. There's ways to monitor this type of runoff, and our AM companies, our sister companies, we have solutions to monitor this, but I don't think we have time today, but this is something that maybe we can do in a future webinar. And then moving on to societal. So, adverse weather conditions on the roadways affect our society in many ways. From longer times in the car, on commutes due to flooded roadway detours or icy roadways, slowing down traffic flow. This all comes down to more stress on the driver due to additional time and awareness required for travel, to travel safely on the roads. Some examples that we don't really think about on a daily basis are road conditions causing a person to be late for work or miss an important family event, such as a recital. A family grieving after losing a loved one, when they're just on a daily commute, to a weather-related traffic accident, all the way to, indirectly where the price of food's going up at a grocery store due to bad weather season for transporting the goods, from the distribution centers to the store. So there's a lot of, things that we don't think about very often, and, how can we mitigate these adverse effects of weather on the roadways, which also directly impact us as a society.
Hi, everyone. Before we continue on, just please mute yourself. We're getting a lot of background noise, and we're unable to mute people. So please just double check that you're muted right now. And even if you think you are muted, please just verify that you're muted, so that way we don't have any background noise, including you, Gary. Thank you.
All right, thanks, Charles. So, as professionals, how can we monitor and be prepared to maintain the roadways, the best way possible? There are many tools and responsive strategies out there that allow maintenance providers to stay ahead of the curve. There's MDSS, which is Maintenance Decision Support Systems. These are road weather forecasting systems that couple ground truth data with forecasted data to guide maintenance personnel on what treatments to apply, when to apply them to get the best possible outcome when managing a storm event. Next, we have weather savvy roads. So, the program is basically a twofold item consisting of Pathfinder, which involves FHWA, NOAA NWS, and private forecasting MDSS companies such as DTN, WeatherNet, and IMO. So integrating mobile observations. This is a collaborative effort between public agencies and private sector to provide the best possible singular public message to inform the motoring public, just exactly, what is going on and what current weather is currently affecting the roadways. The targeted goals of these programs are to bring up cost-efficient operation, proactive management, improve safety, mobility, and economy.
Hey, Brandon, we got a question. What is IMO and how can these tools help an agency?
That's a great question. So, IMO, or integrating mobile observations, this involves collecting weather and road condition data, from the government fleet vehicles, the snow plows, the maintenance trucks, and that are out there during these events. And the focus is on supplemental data from different sensors, installed on the vehicles, such as, the pavement temperature sensors or the meteorological sensors. This also includes the native vehicle data, such as windshield wiper status. Are they on? Are they off? Anti-lock braking status. Have they been activated? Has the TCS, the traction control systems, have those been activated? These are things I think Brett may cover here in a little bit, but to kind of stay on track. The data provides maintenance managers with an extremely detailed view of the weather on road conditions along the road network. And then, this information comes back and then supplements the MDSS, the systems that are after the maintenance decision support systems that we spoke about just previously. And then it also supports traveler advisories, warnings, ultimately resulting in improvement to the safety and mobility of the travelers. Hope that answers that question. Road Weather Index. So Road Weather Index is a series of performance indices that allow winter maintenance providers to put a metric to how well they're actually maintaining the roadway in relation to the capabilities of their organization and the storm severity. How hard is it snowing? It's just another tool that analyze road weather information in near real time. We can also do it after a storm event, and that helps overall in our winter road maintenance strategies. And then finally, field technologies. And now this is where we're starting to get into the meat and potatoes of our presentation today and of what we do here as an organization at High Sierra and One Rain, basically fixed and mobile environmental monitoring stations, the ground truth. Road weather data is gathered, in real time, to provide this data to decision makers about how to respond to changing weather conditions. We'll move on to talking about kind of the field technologies here. Okay, so field technologies. You see the picture here, our traditional RWIS. I think starting off, this is the technology that most everyone has seen on the side of the road and most familiar with. Traditional RWIS are obviously they're fixed locations. They provide many data points: wind speed, wind direction, precip type, rate, amount, air temperature, relative humidity, a lot of environmental and atmospheric measurements. We also get subsurface temperature from the roadway, surface condition, surface temperature, and surface friction. And all this information is very helpful to the decision makers and the input systems to help provide those decision makers with the best information possible. On the downside, traditional RWIS, they have very high costs. Equipment is expensive. It's very robust. Utilities are expensive to get put in. You have to run utilities to these, and most of the time, and then the construction cost, it can get up there. RWIS Lite, or IoT, this is an exciting new area that we're actually moving into at High Sierra. We basically call these non-traditional sites. They typically have less sensors, such as surface temp and air temp, relative humidity, those type of parameters. They cost less, and they're very easy to install. They simply band up to poles or existing infrastructure that's near a highway, such as a sign structure. These can be used to monitor, localized recurring trouble areas. These can also be relocated, which is really cool. They're completely solar powered on the most part, and you can move them around to different locations if you need to, should you have another location pop up. And people use this organization. Some organizations, they'll use this type of solution to fill in the gaps, so to speak, for their their RWIS network if they don't have a mobile system in place, and that is just too mobile. So really, what is the mobile RWIS? We have mobile RWIS is any weather sensor that we're putting on a vehicle, providing information to either the driver via a local display or a central office on the roadway, and that's traveling on that the vehicle is traveling on. It's providing a dynamic measurement of the roadway in multiple locations. And I think I'll just leave it at that and take us down the path of what mobile technology is and what it's all comprised of. Exactly. I'm going to turn it over to our RWIS product manager, Brett Hanson. Before Brett gets started, if you're listening in and you've got your mic unmuted, please do mute your microphone. We're getting quite a bit of background noise. Thanks so much.
Yeah, thanks, Brandon. So yeah, let's. And I also want to thank everyone for joining today. It's good to see everyone here. And so I'm going to talk a little bit about mobile ROS technologies, and starting off with why you would want to include mobile weather data as part of your toolkit for winter weather maintenance activities and just general management of your program. So one of the things with our traditional RWIS stations that Brandon was talking about, there's a limited number of RWIS that can be installed and maintained on the roadway. So we have, and we can have very localized weather across a geographical area. So in between these weather stations can be a large distance, and there can be varying terrain in between. And to get a more robust picture of the roadway, we can fill in those gaps with mobile weather data. And the illustration kind of shows, at the fixed location, the temperatures above freezing, and between we go below freezing. And to get that resolution, we're adding mobile surface temperature data to get that information. So mobile road weather sensors, gives you more data points and hopefully helps you with better decision making power when you're managing your roadways. The ultimate goal is to reduce our economic, environmental, and societal impacts, which Brandon talked about. So how do we do that? One way that has been in use for a long time is taking that road temperature data, and a plow driver takes that in real time with a display in the cab, and can change how much application of chemical he's putting on the road, and hopefully potentially reducing that material usage in general, and reducing the economic impact and the environmental impact of putting more sodium into the waterways. And then also knowing where your fleet is can certainly help with deploying your resources effectively. If you have, if you're showing that the road conditions are deteriorating in one area and not so bad in another, you could potentially deploy more resources in the more impacted area or the higher impacted area. Keeping the roadways clear for increased mobility and reducing those societal impacts of people being able to get to work and moving freely on the road system. And we could also use these in operations to potentially automate some processes. For example, automatically updating road condition reports. Typically, plow operators are calling in road conditions, or there's someone manually entering in a road condition. We could potentially use mobile data to automatically update and improve our information to the public. And I was going to get into different types of mobile weather data out there. So on the OEM side, or this is kind of your standard vehicle, your car, your commuter cars and trucks out on the roadway. A lot of them now have your standard air temperature sensor. So this information is being displayed to the driver, and they can use that to maybe make an informed decision to slow down if their sensors saying that they're near or below freezing, and actually gives them real-time information that they can act on. And maybe in the future, as autonomous vehicles start becoming more widespread, those sensor packages start increasing, and I'll talk a little bit about that later. And on the next level, we have our consumer or prosumer sensors, and this would be like a aftermarket sensor that you would put on your vehicle, after you had bought the vehicle. This would be like a surface temperature sensor, or something along those lines, but maybe it's lower cost, and has a little bit less accuracy standards. But there could be many of them out on the roads that allow you to use that data to do some data analytics and verify that readings are accurate by using a lot of the data. The other type of sensor is kind of your more industrial and commercial, and that's going to be our main focus today, and kind of what High Sierra Electronics provides. They're typically more robust for rugged environments, installing on a plow, or maintenance vehicles that are out in very harsh environments. Typically, there's higher cost for these, but you do get higher accuracy standards. You may not have to check them against another sensor to verify their accuracy. They're accurate out of the box. And then the typical use of these is that government agencies or commercial companies like landscape management, those sorts of things. So
so let's say you mentioned earlier about OEM sensors, and we've got all these newer trucks that are coming out. Let's say I'm a small municipality. I've got a couple of plow trucks. They've got built-in air temperature thermometers on them. It's going to tell me it's freezing outside. What's the advantage to having something that's more of a industrial commercial type sensor?
Yeah, so typically you may have just your air temperature sensor, and that doesn't quite give you the entire picture of what's happening out on the roadway. So the surface temperature can vary fairly significantly from the air temperature. And one example would be if you're driving over a bridge, the main line can be warmer than the bridge, and so you want to know what the actual temperature of the road surface is, because you may want to put down salt on the bridge before anything else. And air temperature alone doesn't quite give you that resolution of what's going on the roadway. And then kind of your more aftermarket sensors have that more that higher accuracy. You can.
So is that mean like they're going down to like a is it more targeted exactly to the degree? Do we get a half degree? I mean, what's the more accuracy mean?
Yeah, typical accuracy is plus minus 0.5 degrees Celsius, so you're, sub-degree resolution on that temperature. Less accurate may be 1 or 2 degrees Celsius difference.
Thanks, man.
So getting into the kind of the architecture of a typical system, you have your sensors that are mounted on a vehicle. These sensors communicate to maybe an in-cab display that shows the data. It also can be connected to a mobile processing unit or an AVL system. It's an automated vehicle locator system that takes the data and stores it and then provides it via some sort of telemetry to a software system where you can visualize the data. Talking more specifically about the vehicle mounted sensors, we have non-intrusive road condition sensors. From us, this would be our mobile eyesight. These types of sensors provide the pavement conditions. So from a moving vehicle, we're providing whether the road is dry, damp, wet, slushy, snowy, or icy. And then also providing a coefficient of friction measurement, basically how slippery the road is from a number from 0 to 1. And these sensors typically also have your road temperature, your air temperature, and relative humidity all in a compact unit. Also, another level of sensor is your surface temperature and air temperature sensor. The surface temperature is typically measured by your infrared temperature sensor and can deliver the data directly to the cab or operator and the onboard controller. And these sensors are typically a little bit less expensive and can be deployed on many more vehicles. Another sensor that we sometimes see is an all-in-one atmospheric type sensor that provides wind speed, wind direction, air temperature, relative humidity, barometric, some of the more atmospheric parameters. And then also on a vehicle, we can get onboard vehicle data. And there's varying degrees of what we can and can't get from a vehicle. But ultimately we want to use the car data to maybe infer some information about how weather on the road, and then air temperature on a vehicle is another parameter that you typically see. Ultimately, we want to know things like the vehicle stability systems. Is the traction control engaged or not, or is the windshield wiper going or on or off? Typically, these are proprietary information, hard to get off of a vehicle. Hopefully, that may change in the future. This would be a big help to know a lot of that data and being able to analyze that. Another type of sensor could be a dash camera as well. So actually looking out the window of a vehicle at a camera image to verify what's going on. I'm sorry, did you just...
Yeah, hey, so the all-in-one atmospheric sensor, that's something that, when I'm out in the field, I really traditionally don't see that on the plow trucks or, a lot. So, what's a typical application for that? I see them on like storm chaser vehicles and stuff like that, but winter weather maintenance work, where would they typically, or why would they typically use that?
Yeah, so an all-in-one sensor, is it not very common, say on a plow, that sort of thing, but it can be used to to get that, more atmospheric data. Typically, you might see it on a first responder vehicle, and like a fire truck where they're being deployed to a fire, and maybe they want to know the wind information, when they're at the site. But they can, in some cases, be suitable for maintenance operations. The one hard thing is keeping them clean and that sort of thing. So the next category that we'll get into is kind of the processing and telemetry of these systems. So we have the sensor on the vehicle, and we can connect it to our mobile processing unit, some sort of vehicle controller that's taking that data and storing it so that we can do something with it. And these systems have GPS antennas that connect to the satellites and provide real-time clock information, your positioning data, so that's your latitude and longitude, so that we know when and where a measurement was taken very precisely. And then that information is sent out to some sort of communication. And the most common type of communication is probably cellular in these situations. So you have an embedded cellular modem that sends the data over an intranet system. And then also some other examples are dedicated short-range communications radios, or DSRC, that uses the 5.9 gigahertz spectrum to send data to roadside units. So the controller's collecting data and then dumps all that data to a roadside unit that can then send it back to some central data point. And another one can be, city Wi-Fi networks, things like that. And one of the cool things about this technology is, even if you're out of cellular range, you can store that data, and then when you get into cellular range, we can dump all that data. So you don't lose what's going on the road. You still get all those data points. You just might get it a little bit later. And then again, that data gets pushed onto some sort of software application, which is kind of the last piece of the puzzle there. And with that, I'm going to hand it over to Charles. He's going to talk about the central software kind of and some applications and how you might use this data.
All right, great. Thanks, Brett. And so as Brett mentioned, I'm going to be kind of talking through what for central software, what are the different types, what are some things that we can look at, and then walk through some of the benefits of using central software. And then I'm going to walk through 3 examples that I think really highlight kind of what we were talking about today. And we can walk through those. So central software, this really is, from a data collection standpoint, kind of that final data path within that larger architecture scheme that we saw. So it is that central point where all of the data is going to get aggregated into. So it's both the mobile data, so all that data that is on telemetry and on plow trucks and division trucks and any other type of vehicle that we want information that's moving throughout a storm. All that data gets combined into a central software, as well as the fixed ROS. So those single point locations that we're talking about, that software or that data is pushed into the software. So combining both the mobile and the fixed, as well as any other camera images that we have, either from the fixed ROS or from plow trucks that have those dash cameras. as well as any other information, including forecast information, as well as any other GIS layer, anything like that. And what that gives you is we call it a single pane of glass view, right? So you have all that information in one spot. You're not pulling up multiple web pages or software that's only on certain computers. All of that is brought into one heads-up display that you can hit it either if you're out in the field or back at the office. There's a couple different types of this with all varying degrees of capabilities and features. So everything from the private industry, including Contra, which we see here, but also MADIS, as well as some traffic management systems, kind of have that ability to collect multiple types of data points. We can create custom notifications that can be routed to the appropriate person. And that really allows for getting that information out for someone who might not be out, who might be out in the field, who may not have their computer up looking at the data. So it works for both kind of the system admin level that is looking at the data and maybe routing resources as appropriate, as well as those out in the field maintaining the roads that might not have a computer screen up and be able to really dig into the detail. We can take that data in, process it, understand it, and then send notifications out as the impacts warrant. And that really helps to system admins as well as individual operators to know when and where to respond based on these different types of data. And including, as I mentioned, the mobile format, pulling it up out of the field. So what are some benefits of having central software? And particularly, why would you want to move that data out from the cab? Like if you had something, a screen in the cab showing the road temperature, what's the advantage of hooking it into one of these MPUs and telemetry and getting the data back in? So as I mentioned before, easily alarm on road conditions. And we can write alarms that spans the different types. So whether it's fixed or mobile, having single alarms that can send out when a threshold's exceeded or multiple locations have hit a threshold, or if it's a certain amount of time has passed and we haven't had a new data point, something like that. We can easily adapt the alarms to meet whatever the operational strategy is for that particular storm or for a particular agency. This data can also be fed into forecast models to help drive accuracy of forecast models. So forecast models, especially with winter weather, they really struggle with not having enough data points. So that is something that, especially when early on in the storm, knowing when those critical thresholds are crossed, as well as what are those road conditions that have been impacted by the operators, and we can feed both the fixed and the mobile data into the forecast models. The fixed provides historical data, which allows us to go back and calibrate biases, do all kind of neat things with forecast models. But the mobile data particularly helps to fill in those gaps and allows the model to know, all right, if it's below freezing in this area, maybe down this ravine, it's likely also below freezing in this other area based on historical storms. So can it really help to drive the accuracy of forecast models and to better understand a storm event, both as it's unfolding and when we're maybe starting to get out of the clear based on that increased data volume. As I mentioned before, a single view. So combining the mobile and fixed data, the cameras that are either on the dash or on those fixed ROS sensors, as well as that forecast model data that we're looking at. So we're helping both increase the accuracy as well as display it all on one screen, so we can understand conditions throughout an event. We can also we store all this data forever. So we're able to go back after an event and run reports, look at trouble spots, see how a particular event unfolded, and it really helps to be prepared for the next storm, or the next storm that's similar to the one that just occurred. So if we're documenting where those trouble locations are, and for example, a particular bridge that continually has frost conditions and we continue to have ice formation, we can record it and not have it be institutional knowledge or with a particular driver. We can document that information and then pass it on and maybe change route optimization or look to do some sort of other mitigation work for those particular areas. So documenting that mobile data is really critical to start building up a history of your trouble areas that most of the time is already known, but it does help to provide some quantitative data as opposed to using qualitative and institutional knowledge. And then we can also use that central software for varying road issues and seasonality. So especially when we get into wet weather, so some of those environmental issues that Brandon touched on, including water quality, it can be directly related to what we've done in the winter, and can be directly related to not being efficient and optimizing during our winter weather work. So as Brandon mentioned, there's a variety of solutions out there, but having one central software that can handle both the winter weather work and that mobile weather, winter weather information, but also having the ability to handle, say, low water crossings, so particular roads that flood, or water quality tracking to see how our winter weather operations have impacted different watersheds, especially over time. So bringing that data into one spot makes the seasonality work a little bit easier, especially from season to season.
Charles, and that really does make sense because, in some locations, yeah, it could be snowing, like crazy up on top of the mountain, but then also in that same event, maybe dumping tons of precip down the valley, and to be able to get the flooding information and the water level information, as well as the snow information at the same time, it can be really helpful, I think, to be able to see all that in one spot.
Yeah, that's a great point, especially as we get into these types of spring storms. If we're having any sort of rain on snow event, having a single view that you can combine both your winter weather and any of your hydrology needs or general meteorological needs, having one software combine all that information makes it reduces the risk of data slipping through the cracks or completely missing an event. All right, so with that, I'm gonna walk through 3 scenarios that really highlights kind of what we were talking about today. And the first scenario is a frost warning application. So this occurs, as most of you probably know, but it's worth just refreshing us. This occurs when the road temperature is below freezing, right? But the dew point temperature is above the road temperature. So we can see this is real data from an actual storm. Looking at the red line here is the road temperature, and we can see when that road temperature is below the green dew point line, we can enter into frost conditions, and can be some really dangerous situations out there. So in the red block there, we can see we're completely frost covered, and then as we get closer towards when that road temperature warms up past the dew point and then eventually on past the air temperature, we're starting to get into partially covered frost. Now this can vary a lot over our road segments and over our domain. So it might be in some areas depending on the topography and how the roads are set up. And so what we can do is that sensor that Brett was talking about earlier that measures air temperature, dew point, and road temperature, a relatively low-cost sensor can provide a lot of value for detecting these type of frost warning situations. So we have the three values that's most important for tracking this. So air temperature, relative humidity and dew point, as well as road temperature. So we are able to, obviously we have those on the fixed RWIS locations, but we're able to get that data in between those fixed RWIS points and really to get a better sense, maybe leading up to an event or following an event if we're heading into these types of frost warning conditions. And then, as I mentioned earlier, this can also help to drive and verify what the forecasts are saying, as well as to understand if there's other areas or trouble spots in our domain. It's occurring in one spot, we're likely to have in others. So we can better understand these frost conditions and deploy resources as needed. All right, for my last two, we're going to actually look at a real life scenario here using actual software. So fingers crossed on a workable demo here. So here's an example. This is I-80. It's a little hard to read here, going over the Sierras and then continuing on to Truckee and Reno. And as we look at this pass here, we have our two fixed ROS locations, one on I-80 and then one on the state road that joins up with I-80. And we can see at the pass here, which is really the most common place that we put these types of fixed ROS stations. We see we have a road condition or surface condition sensor that is measuring snow and ice, which depending on the type of the season we have is not uncommon for this to be snow-packed for an entire season. So we know what the conditions are up at the pass, but further down the hill as we go, we see we have one surface condition sensor that's just showing wet. And so right above this wet sign, actually on I-80, there's a dynamic sign that we can change and warn motorists ahead of those conditions. Now, the trouble with this is obviously if we've had snow compaction all year, maybe motorists are used to seeing that warning and they just continue driving. But we also don't know anything about, hey, is it just really right at the pass as it moved down the hill and it's really just on the other side of this wet sign? The more information that we can provide motorists, we can help them to be more aware of the conditions and act appropriately. So in this case, if we turn on our mobile data, as well as turn on our thresholds here, we can see that we can really help to fill in the gaps here. So this light blue and dark blue is wet and damp. This is using real surface condition data that was driven for the last big storm up here. And we could see it's really changes to ice, that red threshold there, right before those conditions, right before that fixed ROS site. So maybe we're able to adjust the dynamic sign to let them know maybe how far up, as well as we can assign resources for the other side of this fixed ROS that's maybe having some issues with the roads and keeping the conditions appropriate. So you can see it is continually updating behind the scenes. So as trucks are driving, we will update with the latest data points, so you can make decisions and change that sign. The other thing that we can use to leverage is Brett kind of touched on it, is instead of relying on the operators in the trucks to send in the actual road conditions, which is quite common, we can actually use this mobile data with some vetting, with some quality control, as well as maybe some minimum thresholds that we want to set for surface friction. We can automatically update the road conditions, and we can see exactly where we're driving. The operator is able to focus on the road and focus on their job, and maybe just oversee what information is getting pushed out. then the software is able to aggregate that fixed data as well as that mobile data to adjust what the public sees, or keep it behind a username and password and just what the system administrators see. All right, for my last example, just finish up very quickly here. So this is the system out in Overland Park. And really what we're going to look at is when we look at pavement state, we're able to get that information. So our fixed ROS locations throughout the city, what are those conditions? We're also able to bring in the snowplow operations and what they've treated, what road segments they've been on, whether the plow is up and down. All that gets fed into a third-party GIS system, but we're also able to take that mobile data and couple it with that snowplow operations as an independent data feed, gets combined on the back end, and then when we visualize it, we have both what has been treated, what the plows, whether they were up and down, as well as helping to fill in the gaps of what these fixed ROS sensors. So with that, I'm going to pass it back to Brett, and Brett is going to cover the future of mobile ROS and kind of where we're going.
Yeah, thanks, Charles. Yeah, so the future of mobile ROS, and this is just a couple different examples. Certainly, there's a lot of exciting things that will be happening in the future, but I just want to touch on a couple things. The first being, using big data, or analyzing large data sets. This would be kind of the example that I touched on a little bit earlier, where you may have a prosumer type sensor on thousands or hundreds of thousands of millions of vehicles, and you have millions of data points that you're trying to make sense of, and using machine learning and those types of things to take that data and use it to get a ground truth, what is actually happening on the pavement, and using that data to populate road weather models and improving our road weather model accuracies. That is one of the bigger things that using a lot of data for would be very beneficial. An example would be, in the trucking industry, Brandon touched on that they lose a lot of hours due to weather. Well, we could plot a route on a map, and if you know when the conditions are going to deteriorate at a certain time on that route, when they're going to be there, you could potentially route around those weather impacts, and keep the flow moving, the trucking economic flow moving, maybe reducing traffic in those trouble areas, and keeping, congestion is a very big deterrent of being able to keep the roads maintained. So if you can keep less cars on the road in a snowy road, it's easier for the plow drivers to keep that road clear, and increasing, mobility. And then and the other application that is a very big topic today is connected vehicles. So autonomous vehicles are starting to kind of show up on the roadway, and will continue to be something that we will need to deal with, as far as how do autonomous vehicles deal with weather. And one of those, so connected vehicles is part of that discussion. So vehicle to vehicle is a vehicle talking to another vehicle with some information. So an example would be, I'm driving down the roadway and I start slipping because there's a patch of ice. And my car tells another car behind me, hey, there's some ice on the road. It might be a audio or visual alarm to the driver, and they're able to slow down as they approach an impacted area. Or it's an autonomous vehicle and the vehicle automatically slows down. Also, vehicles can talk to infrastructure. So this would be a vehicle sending data to a roadside tower, and then that going to a central data point, and then doing something with that data. And that something could be talking to a group of vehicles that are farther away that the vehicle can't talk to the other vehicle. So it's providing data to a vehicle farther down the road. And the OEMs are starting to integrate some of this technology, and it's going to become bigger and bigger. And having sensors that can deal with these, the weather on the roadway will be beneficial for these technologies. So yeah, those are just a couple of things that I wanted to point on there. And with that, I'm going to hand it back over to Brandon, and he's going to talk about some of the takeaways.
Yeah, so guys, thanks again for joining us. I'm going to wrap these pretty quick so we have some time for a couple questions. So for today, there's still work to be done to keep our roads safe via policy, road improvements, adding infrastructure, adding more sensors to the roadway. So, having it out there. Mobile RWIS is definitely one weather responsive traffic management strategy in a very large toolkit with the MDSS and the IMOs and the mobile gap filling. And it gets to the next thing. So, mobile RWIS is definitely useful for filling in those gaps between our traditional and our fixed RWIS stations. And, the data can be used in operations to eventually make some of those tasks and those notifications and those alarms all automated. Do we automatically change, the message signs and let the motorists know what's going on? And, one thing that we do know is that the future of mobile is looking super promising. And with the connected vehicle on the rise and the talk about self-driving plow trucks, I think mobile RWIS is very promising, and it's going to be here to stay. So, be aware, be responsive, be thorough, and be equipped for the future. So with that, I'm going to open it up. If anybody has questions, feel free to unmute yourself, take the floor. If not, here's our contact information. Feel free to reach out to any of us. Give us a call. We'd be glad to chat with you about what we went over today. And we'll also have this webinar put up on our website as a recording. So if you'd like to go back and catch something that you might have had to step away and miss, it'll be out there for future viewing. But we really appreciate you having the time to join us today. And looks like James Logan has a question on here real quick. Can you view the mobile data from the application in a cab? Brett or Charles, do you want to take that, or would you like me to answer?
Yeah, I can answer that. Yeah, so what's really important for looking at mobile data in a cab is both having some sort of display in the cab to look at it as they're driving, as well as have the ability for the software to be viewed on mobile or a tablet with the same functionality, so being able to see that data that gets pushed out to the central software. And then that allows the operator to visualize things such as thresholds, to view troubled road segments automatically once it's pushed to the central software, just to get additional contextual information.
And just to add on to what Charles just went over, we also have the ability, our pavement and temperature sensors are integrated with some of the leading plow controller technology companies out there. So it's plug and play. You can put that in there and see that temperature, air temperature, and pavement temperature information right there on the plow controller display. Any other questions that might be out there? Well, again, it looks like we're at 2 o'clock. So, I mean, if you have a question, feel free to ask real quick here. But if not, again, please email us, and we really look forward to hearing from you. And we'll hope to have another webinar for our RWIS division here in the upcoming months, especially before we get into the next maintenance season. So, again, thank you very much, everybody, and be safe.